The next one appears to be a hyperbola. Here's the equation. Okay. Apparently you didn't know how to do this one. There's a lot of blank spaces here. Okay. The standard form of the equation still needs to equal 1. And the thing that they had already done for us on the previous problem that we need to do now is complete the square. So the first thing that I'm going to do is group the x's and the y's together. And then I'm going to start by factoring out the leading coefficient on the x and the y. Actually, I'll do them both. In the case of the y, the leading coefficient is a -1, right? We want to get rid of that negative if possible. Okay, now you take half of the b term inside of this little quadratic we have here, square it. Half of this b term happens to be 2. We square that, so that means we add 4. We take half of this b term, which is 3, square it, which means we're actually adding 9. Okay, so let's look at what we actually just did, right? We just added 4 on the inside of this parentheses, so what we really did was add 12 here, right? The 4 times 3. We really added 12 on the left side. And over here, we actually added -9, right? We added a 9, but it's actually a -9 because of that -1. So what I'm going to do is, if we do it to the left, we have to do it to the right. So I'm going to go ahead and do that. Add a 12, add a -9. Looks like we're going to get 3. So we're left with this. I think it's equal to 3. Okay. If you know anything about completing the square, you will know that this quadratic over here, well, we have 2, but the one with the x's, right, we can factor that, and it turns into x minus 2 squared. In fact, that was the point of completing the square, was so that we could factor it into a term that looks like this. We're going to do the same thing for the y. And if you don't believe me, you can FOIL out this x minus 2 squared or this y plus 3 squared, and we'll get back to where we started, right? The last step is to divide by 3, right? In the standard form of hyperbola, we want it to equal 1. So we're just going to do this. And as you can see, the standard form will end up looking like this. Oh, sorry. This is actually a 1. A 3 divided by 3 just gives us a 1 as one of our terms, and a 3, and it's all equal to 1, because that's what the standard form should look like. So, that's the first part. I'm going to go ahead and erase this work. If you need it back, you can just rewind the video, I suppose. Okay, so now what we're going to do is the little details, right? We're going to find the center, the vertices, the foci, the asymptotes, the eccentricity, etc. Okay. Center. Well, that's the easiest part, right? It's 2, -3. Obviously, these coordinates come from the equation in standard form. which is one of the advantages, right? So once we know how to complete the square, we can find the center of our hyperbola. And actually the center is like imaginary, right? The hyperbola doesn't really pass through the center. It's just like it tells us where to start drawing our box. Okay, vertices. For this one, I'm just going to sketch the graph and picture what I'm doing. Right, we go over 2 in the x, we go down 3, which means our center is here. In the x direction, we're going to go left and right by 1. In the y direction, we're going to go up and down by the square root of 3, which on my graph, it's pretty close to 1.5, so I'm just going to go with that for now. Okay, so that kind of tells us where to draw our box, right? So our vertices are going to be right here and right here, which in the x direction we only went left and right 1. So the vertices are going to be 1, -3, and 2 plus 1 is 3, -3. Now if we fill in our asymptotes, oops, then we can kind of see what this hyperbola is doing, at least approximately. Okay, foci, right? Foci are always going to be out here. And the way that we find those is the same equation as Pythagorean theorem, although it's actually, as far as I know, it's not related to Pythagorean theorem. So we just do 1 plus 3, we get 4, we find out that c equals 2, right? C squared is 4. Kind of skip that step. So if the focus is 2 away from the center, then we're going to take the center and add 2 to it in the x position. So one of the foci is at 4 and the other one is at 0. So clearly my drawing is off a little bit, but that's okay. Asymptotes. So the thing about the asymptote is that the slope of the line that is the asymptote is related to the size of the box. How is it related to the size of the box? I'm going to have to draw a little bit bigger picture to show you the why. So I will do that. Okay. And I'll try and be a little more precise as well. So for the x direction, we went to here and to here. In the y direction, we went square root of 3. I'm going to approximate that a little closer this time. Square root of 3 is around 1.73, so that might put us about right here. And right here. Okay, so now we have our box. Now, if you notice, what is the height of this box? It is 2 root 3. And what is the width of this box? It is 2. So if we drew a diagonal, which ultimately will become our asymptote, right? We can already kind of tell that the slope is proportional to the dimensions of this box, right? Slope is like change in y over change in x, and if we just imagine starting at the bottom left of this box and moving to the top, as long as both of these points are on the line, this will work, right? We had to go up 2 root 3, and we had to go over by 2. So the slope is root 3, right? In general, that's just going to be the y number divided by the x number. In this case, it was the square root of 3 divided by 1, right? If you notice, we would have to square root this, right? This is like a squared, and this is like b squared. This equation requires maybe a and b, right? But you know how to find the slope of a line in general, so I'm not going to go on and on about this. What you do need to know is that what is the slope of the other asymptote? Well, it's exactly the same number, but it's negative, right? So if we had imagined going from this point to this point, we would have gone down 2 root 3 and then over 2. So the slope of the other asymptote is just going to be negative root 3. Okay. Now, the other thing that we need to know is what point does it go through, right? If we have the slope and a point, then we can adequately describe any line. And since both of these asymptotes should pass through the center, which is located at 2, negative 3, we have enough information. Now what I'm going to do is just apply this formula. This is called point slope. I'm sure you've heard of it. And I'm going to do it for both of the slopes for the different asymptotes, but using the same point, right? They both pass through this point here, through the center. So y plus 3 equals positive or negative root 3 x minus 2. So this is really two equations. We get y plus 3 equals root 3 x minus 2 root 3, or y plus 3 equals negative root 3 x plus 2 root 3. We subtract 3 from both, we get root 3 x minus 2 root 3 minus 3, or y equals negative root 3 x plus 2 root 3 minus 3. And these are the equations of the line. The only thing that you need to know is that, like, basically this part in parentheses, that's kind of like the y-intercept, right? Which would be difficult. We'd have to round it if we were going to graph it, because it's not a whole number. However, these are the equations for the asymptotes. And I think using these little bits of algebra, it's pretty intuitive where these come from, right? Okay, let me go back. The eccentricity. Okay. The eccentricity is always the c value divided by the, wait a second, I better look this up. The eccentricity for a hyperbola right. In this case, the semi-major axis is the y-axis, right? Because the major axis is here. In other words, this is the axis along which the hyperbola opens. So the semi-major axis value is square root of 3. So our eccentricity is 2 divided by the square root of 3. Okay, again, I'm going to stop this video. That was the, let me just make sure. Yep, that was the end of this part. And I'll move on to the parabola next.